Who's out there? Anybody? Yep. On Friday. Kind of prepping a little bit right now. I just decided to go live, prepping just a Okay, so we've got an interesting situation today. So we are solving quadratic equations. That's the gist for today. We're solving quadratic equations. This is a video that I think, so replay people, live stream people, welcome. It's starting now. I think this is a video that will get a lot of views because we're going to watch it on repeat. And I suggest that we watch it on repeat just to get this rhythm and this pattern down. You learn it once, though, and you're golden. And full disclosure, the method for solving quadratic equations that I'm going to use is something that I have personally never taught before. It is a new method that I have learned. It is actually a new method that was discovered, in quotes, discovered in the year 2019, just last year. But I saw it and I thought it was very impressive and something that I think I should be teaching. And so I took the time to learn it. And that's why right now I'm not looking at our notes, because that note packet, that sheet of notes was designed without this train of thought that I have now. So I'm going to do a little bit of free form notes right now, and then we'll look at some examples from the examples that are posted on Canvas. So a little bit of quick review, okay? A little bit of quick review. Let's remember the distributive property, okay? Let's remember the distributive property. The distributive property, let's say I had this right here, and I said multiply those two things together. Well, the distributive property says that that's equal to, you do one thing times one thing, so x times x, which is x squared, and x times negative 5, which is negative 5x, and 3 times x, which is 3x, and 3 times negative 5, which is negative 15. We can combine our like terms together, negative 5x and 3x, and we're left with x squared minus 2x minus 15. That's a review of the distributive property that hopefully feels familiar. And I want to take a quick look at our end result here. Our end result here, let's look at these two numbers, negative 2 and negative 15. Negative 2 is the sum of positive 3 and negative 5. Negative 2 is the sum of positive 3 and negative 5. And negative 15 is the product of 3 and negative 5. That's not a coincidence. That's how it pans out. So let's just kind of keep that in the back of our brains. Let's look at another example of the distributive property. There's nothing special about x. I can use u or y or z. Let's take a look at this one here. 6 times 6 is 36. Negative u times, or I should go in the same order I did last time, right? 6 times u is 6u. Negative u times 6 is negative 6u. and negative u times u is negative u squared. So when I combine my like terms here, these guys actually end up canceling out, which is kind of neat, is it not? Right? So because I had a minus u and because I had a plus u, 6 times a positive u and 6 times a negative u, they ended up canceling out. So just kind of a nice, cute occurrence that happens there. Okay? So what's useful about being able to combine these two things? What's useful about the fact that this equals this? Because that's what we're saying right there, right? We're saying this is equal to this. When I multiply them together, these two things are equal. Well, what's so special about that? Well, what if I gave you the equation 0 equals x squared minus 2x minus 15? All right, what if I gave you that guy right there? Well, I could rewrite this as x plus 3 times x minus 5. Could I not, right? These two things are equal. We just proved that up here, so to speak. We proved it. So if that's true, well then, if I make this thing 0, or if I make this factor 0, well then I'm making it equal to 0 because 0 times anything equals 0. So if I set this factor equal to 0 and solve for x, I get x equals negative 3. And if I set this factor equal to 0, then I get x equals 5. Those are my two solutions to this equation. Don't believe me? Plug it in. If I plug in negative 3, yeah, this comes out to negative 8, but who cares? This results in 0, and 0 times anything equals 0. It works. Plug in the other answer. Yeah, sure, I get positive 8 right there, but positive 8 times 0, because 5 minus 5 is 0, equals 0. That checks out as well. So both of those solutions work. So the breaking up this thing into this thing is called factoring, okay? And that's not something new to me, all right? That's not something that's new to me. And that's probably not something that's new to you either, the idea of factoring. At least I hope factoring isn't sound like a new concept. It's somewhat mentioned in Algebra 1. But I'm coming at this from a new perspective. What's a better way to factor? Right? So let's give us a whole new problem here. Let's solve x squared plus 4x minus 12 equals 0. We want to rewrite this thing right here as x, something like that, right? That's the point. I'm trying to mimic what we had above. But I spoiled the answer, right? I already had the factors and we went this direction. I already had the factors and we went this direction. Now I'm just giving you a random equation. So how do we come up with these factors so that way we can solve for our two solutions, just like we did here, right? How do we come up with that? Well, again, let's go back up here. What was the pattern here? These factors, what was the pattern? These two numbers added to negative 5, or sorry, added to negative 2. These two numbers added to negative 2, and they multiplied to negative 15. So the two factors multiplied to the or added to the middle number and multiplied to the last number. That ought to be something that you've heard before when it comes to factoring. I'm almost certain of it. So traditionally speaking, when we factor, I won't write that sentence. We're looking for two numbers that add to, what are we looking to in this case? That add to the middle number and multiply to be, I'll say product. It's a better word to use there. And their product is negative 12. That's what satisfies these two numbers right here. We're looking for two numbers that add to 4 and multiply to negative 12. Now, let me tell you what I would have told you in the past. I would have said, well, guess and check. What two numbers multiply to negative 12? What two numbers multiply to negative 12 and add to 4? Well, negative 1 times 12, that equals negative 12, but it doesn't add to 4, so that one's out. Negative 2 times 6, that equals negative 12, and negative 2 plus 6 equals 4. We just found our winners. Okay? That was easy because these numbers are smaller. Okay? Let me show you the method that we're going to use from here on out. I don't want us to have to guess and check. Okay? This is how I would have taught you in the past. We just got our two factors, x minus 2, x plus 6. That's going to be our answer, okay? Or not our answer, but that's going to be what these two factors are. But I want to pretend like we don't know the answer yet. I know that seems quick, and you're like, well, why don't we just do it that way every time? Because it doesn't always work, okay? For future problems, that doesn't always work, and I want to show you a method that works every single time. So, what is our method here of getting two numbers that add to 4? Like I said, I haven't taught this before, and I want to make sure that you understand, and I want to say it in a way that I'm proud of. So, two numbers that add to 4 have an average of 2. That's not a very profound thought. Two numbers that add to 4 have an average of 2. Okay? So 1 plus 3 is 4. There's two numbers. What's the average of those two numbers? Divide it by 2. Boom. When you average things together, how many things did you add together? Divide it by that amount, right? So if I only added two numbers, I'm just simply dividing this number by 2 to find the average. If the sum of two numbers is 4, divide that by 2 to find the average. Okay? So the two numbers that add to 4 have an average of 2. Okay? Two numbers that have an average of 2 follow this, or maybe not follow, have this form: 2 plus u, 2 minus u. Okay? So I'm saying, we're again, what's our task here? We're trying to come up with two numbers that add to 4, multiply to negative 12. I'm saying those two numbers take the form 2 plus u and 2 minus u. I'm really explaining this one out, and it might seem daunting, but when I do the next one, I'm not going to over explain as much, and it's going to seem easier, I promise. that if this is feeling difficult at all. So they add to, so do these, I mean, let's double check, right? Let's double check. Do these two numbers add to 4? 2 plus 2 is 4. U minus U cancels. Yes, they add to 4. So check. They add to 4, right? Not blowing your mind there, right? Hopefully, right? So they add to 4, and we need them to multiply. We need them to multiply to negative 12. So let's do 2 plus U times 2 minus U. And we want them to multiply to negative 12. Does this right here look familiar? Because I wrote this problem up here like this for a purpose. Remember how things canceled out? It's going to cancel out again. 2 times 2 is 4. 2 times negative u is negative 2u. U times 2 is positive 2u. U times negative u is negative u squared. They canceled again, right? I showed you that example previously on purpose. So now let's solve for u. So we're going to add u squared to the other side. I don't need to write that out. Do I need to write that out? So u squared goes over here, and then add the 12, and I get 16. Should I write that out on this one? Sure, I'll write it out on this one. So add the u squared. And then add the 12. And then how do I get rid of the squared? I take the square root. I'm hoping that some of us can do that in our head, right? And that those steps don't take nearly as long. So u is 4. So like I said, the two numbers take the form 2 plus u and 2 minus u. Therefore, our two numbers are 2 plus 4 and 2 minus 4, 6 and negative 2, which are the same numbers that I got through guess and check up here. So we just found our factors. X minus 2 times x plus 6 equals 0. So therefore, our solutions are 2 and negative 6. Because again, what makes this 0? This factor needs to be 0. So when I plug in a 2, 2 minus 2 gives me 0. 0 times anything is 0. Okay, so that might have taken me too long on that one. I might have over-explained a little too much. Let's do it again. Okay. Let's do it again. Switch up to another color other than black here. So x squared plus 6x minus 216 equals 0. What our main goal is to factor this up into x and x. And what are these two numbers, right? There's number 1, there's number 1, and there's number 2, right? There's two of them. These two numbers need to have a sum of 6 and a product of negative 216. Okay? That's the pattern every time, right? To scroll all the way back up here, right? These factors followed that pattern, okay? That's just the pattern every single time. When you factor something up, those two numbers will always add to the middle number, as I like to say, and multiply to the last number. The two factors will always add to the middle number and multiply to the last number. And again, this is where I would tell students to guess and check. Now, with those smaller one-digit numbers, it was pretty easy to guess and check for 6 and 2. What two numbers multiply to negative 216 and add to 6? I genuinely do not know the answer off the top of my head. I don't. I can't even think of two numbers that multiply to 216 very easily, right? I can try a few, right? But in my head, not so much. With the calculator, yeah. But I think what we're about to do on the page is a lot more manageable in your head and quicker than guessing and checking, okay? So, again, what form do these two numbers take? They need to add to 6 and multiply to negative 216. So, numbers that add to 6 have an average of 3, to repeat my phrasing that I used up here. So the two numbers that add to 4 have an average of 2. And two numbers that have an average of 2 take the form 2 plus u and 2 minus u. So to use my phrasing there again, two numbers that add to 6 have an average of 3. And numbers that have an average of 3 take the form 3 plus u and 3 minus u. So when I multiply these two numbers, I don't know what they are, but when I multiply them together, the result should be negative 216. Because the sum of these is obviously 6. If I were to add these two together, the u's cancel, and 3 plus 3 is 6. But when I multiply these together, their product needs to be negative 216. I'm going to skip immediately to 9 minus u squared, because the middle term is going to cancel just like in the previous example and the one before that. I'm also going to do a little bit of this in my head. I'm going to add the u squared over, and I'm going to add the 216 over, which is 225. When I take the square root of that to solve for u, I get 15. You might have to break a calculator out for that one if you don't know that one off the top of your head. So, what are the two numbers? 3 plus 15 and 3 minus 15. The result is 18 and negative 12. So my factors are x plus 18 times x minus 12. And the result gives me two answers of negative 18 and 12. Because again, yes, these are my factors. However, when I plug negative 18 in, negative 18 plus 18 gives me 0. 0 times anything gives me 0, and it works. I'm right here, Mr. Skis in the future. I'm gonna highlight this part of the video right here. Let's make a generic description of this, okay? Can we make something generic here? If I've got this right here, x squared plus bx plus c equals 0 in front of me, okay? And I'm trying to factor this, well, I'm going to be looking for two numbers that add to the middle number, which is b, and multiply to the last number, which is c. Well, two numbers that add to b have an average of b over 2. Half. It's always half that number. 6 divided by 2 was 3. And where was it? Up here. Sorry. And 4 divided by 2 is 2. So in general, you always just divide by 2. So those two numbers will take the form of b over 2 plus u b over 2 minus u. And those two numbers need to multiply to equal c. And then you solve. That's what we're going to do every single time. Another example. X squared minus 5x minus 14 equals 0. Gonna make this one a little bit more challenging. But when we factor it, we're following the same thing, okay? We're trying to figure out what these two numbers are. These numbers are a little bit smaller. You might see it guess and check wise, right? Again, what are we looking for? We're looking for two numbers whose sum is -5. They add to the middle number, -5, and multiply to the last number, -14. Well, they take the form -5 halves plus u and -5 halves minus u. Again, you might be able to do guess and check, right? And more power to you to be able to guess and check. What two numbers multiply to -14 and add to -5? 1 and 14, 2 and 7, what's the combination, right? You might be able to see it, but this works every single time, and that's why I'm going to do it this way, because you won't regret it being able to do it this way. So the average of -5 is -5 halves, and we do plus u minus u. And when I multiply this together, remember the middle term's going to cancel out. Let's see that again, how it cancels out, just in case you don't remember. So when we do -5 halves times -5 halves, that becomes positive 25 fourths. 5 times 5, 2 times 2. And then -5 halves times -u is positive 5 halves u. And u times -5 halves is -5 halves u. Again, that's how it just cancels out. Minus u squared equals -14. So 25 fourths minus u squared equals -14. I'm going to add the u squared to this side and add the positive 14 over to this side. Again, I am skipping some steps visually here, but I hope you're with me on that. This is a skill that maybe we don't all have in our back pocket, but it is something we learned in 4th and 5th grade, and that's adding fractions together. So 25 fourths plus 14. I just need to get a common denominator. So I multiply by 4 over 4 to get a common denominator. And so this becomes 4 times 14 is 56 over 4 plus 25 over 4. Now those two things can easily be added together. I end up with 81 over 4 equals u squared. Take the square root. I end up with 9 halves equals u. So if 9 halves equals u, what are my two numbers? -5 halves plus 9 halves, -5 halves minus 9 halves. So -5 plus 9 is 4 halves, which is 2. And -5 minus 9 is -14 over 2, which equals -7. So my two numbers are x plus 2 times x minus 7. I'm sorry, I'm kind of jumping around with my work there. But hopefully you forgive me on that. So my two solutions are x equals -2 and x equals 7. And again, sometimes guess and check is easier. And if you saw that, when I asked the question, what two numbers multiply to -14 and add to -2 or -5? If you're able to see -7 and 2, right? -7 times 2 is -14. -7 plus 2 is -5. If you can guess and check your way to those two numbers quicker than this, more power to you. However, I am trying to train you in this moment to get used to this one because there will be moments where it's not that easy to guess and check or impossible to guess and check. And I don't mean that word lightly. And we're going to want to know how to do this. So, I could open up the notes and just do some. I'm just going to pound out like a million examples. I think if I do like a million examples and if everyone takes the time to watch 3 or 4 or 5 or 6 of them, right? I've got this big, yeah. I feel like I said a lot, and I'm probably saying more than I'm used to because of the fact that um I haven't used this method a lot personally. However, I think I think if we all do it a lot, right? I mean, you 8 folks here who are watching, right? It's my program here is telling me I have 8 viewers. I mean, you're in here on the groundwork, and you just keep doing it, right? Because we're not just gonna do this once and be done, right? We're not learning this for today and then forgetting it tomorrow. We're gonna use it again the next day, and the day after that, 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 and the day after that. So we ought to all be pros by the end, I would imagine. Um, I'm gonna crack open the notes here and just do like a whole lot more examples. And yeah, let me open those up. If you have printed the notes and now we've seen it a few times, you might try to beat me to it a little bit on a few of these. If you can. So when I look at this, again, we want to. I'm going to shorthand some of this, right? I was writing sum and product every time. How about I be a little more quick and say, so it's going to add to 1, it's going to add to the middle term, and multiply to the last term. Two numbers that add to 1 have an average of a half and will take the form half plus u, half minus u. Those two numbers need to multiply to equal -30. So I end up with 1/4 minus u squared. That middle term's always canceling, right? You're going to make things a lot more efficient if you don't have to realize what's canceling. So a half times a half is a fourth, and u times -u is -u squared. That middle term is canceling. I'm going to move the u squared over, and I'm going to move the -30 over. So I get 1/4 plus, I'll write the 30 first. 30 plus 1/4 equals u squared. I need to get a common denominator. So I end up with 120 fourths plus 1/4, which equals u squared. So 121 over 4 equals u squared. Take the square root. I end up with 11 halves. These notes were not designed with my method in mind. I'm kind of running out of room. So the first number is 11 halves, or sorry, 1/2 plus 11 halves, which equals 12 halves. And the second number is 1/2 minus 11 halves, which equals negative 10 halves. So my two factors are x plus 6 times x minus 5. Because 12 over 2 is 6. Negative 10 over 2 is negative 5. So my two solutions are x equals negative 6, x equals 5. And I'm going to do it again. Like I said, the guess and check method can be easy on some of these. What two numbers add to 10? What two numbers add to 10 and multiply to 25? 5 times 5 is 25. 5 plus 5 is 10. So those two numbers, 5 and 5. I'm done. So it just equals negative 5 twice. It really is that quick. It really is, right? Give me two numbers that multiply to 25 and add to 5. 5 times 5 is 25, and 5 plus 5 is 10. Boom. That's the answer. Negative 5. Twice. Okay? But to prove my point, and to just show you another example, not to prove my point really, just to show you another example, they're going to take the form 5 plus u and 5 minus u, and the product has to be 25. So I get 25 minus u squared equals 25. Subtract the 25. Oh, this is kind of interesting. This one's kind of interesting, right? So I'm going to move the u squared over, and I'm going to subtract the 25, and I'm going to get 0 equals u squared, and I take the square root, u equals 0. That's actually kind of interesting, right? Because 5 plus 0 gives me 5, and 5 minus 0 gives me 5. So my two factors are x plus 5, x plus 5. Huh. So the solution is x. That's actually kind of cool. So I need two numbers that add to negative 2 and multiply to negative 15. Take half of this number, add u minus u. So negative 1 plus u, negative 1 minus u equals negative 15. You could speak up and stop me on any of these examples at this point, right? I feel like I have the gist of a good video that people can rewatch over and over. You're still watching. You're still with me. Well, I already gave it away. Let me finish this one. Well, you can still ask a question, but I'll ask you some questions. So I took half of negative 2 and got negative 1 plus u minus u. If you don't quite 100% understand why I'm doing plus u minus u, that's understandable. And if you go back and rewatch this some other time, I wouldn't do it right away. I'd take a break. But if you go back and rewatch it some other time, what I say when I brought that up the very first time might make sense again, right? Once you see it in retrospect. So -1 times -1 is 1, and u times -u is -u squared equals -15. So I'm going to add the 15 over and get 16. I'm going to add the u squared over and get u squared. Take the square root. U equals 4. So -1 plus 4 and -1 minus 4. That's 3 and -5. So my two numbers are x plus 3, x minus 5 equals 0. So my two solutions are -3 and 5. All right, so help me out on this one. I'm looking for two numbers that do what? Right? I look at this equation and I'm trying to break it up into x plus or minus something, x plus or minus something. That's the goal. So those two numbers need to add to what? There's 7 of us still here in the chat. They need to add to what number? Little Nat is right. They need to add to -8, the middle number, right? Think of it as the middle number because it is. And they need to multiply to -48. Lil Nat is right. Add to the middle number, multiply to the last number. These two numbers will take the form of what? The number here is always what? It's all like, if could you be generic? We divide by 2. We divide the middle number by 2, -8. So we end up with 4 plus u, 4 minus u. These are our two numbers. Like these are like an equation for our two numbers, all right? They have to take that form. Like it logically, it just, I mean, if you think about it, right? We can dwell on this problem. Let's dwell on another problem, right? Why does that work out? Why does that make sense? Why do they have to be that? Well, two numbers, when they add to -8, have to have an average of -4. Whoops, I almost didn't write the negative. Whoops. Let's say, to ignore the negative for just a second, let's just say it was 8. Give me two numbers that add to 8. 1 and 7, right? Well, what are the average of those two numbers? 1 plus 7 is 8, divided by 2, it's 4, right? Give me another two numbers that add to 8. 2 and 6. What's the average of 2 and 6? Well, how do you find the average? You add the two numbers together and divide by 2. Well, that's 8 plus 2. I get 4. Give me two numbers that add to 8. 3 and 5. Well, you get the point, right? They're always going to have an average of 4. And what we're saying here with this u value is that these two numbers add a little bit to one number, add a little bit to 4, add a little bit, or subtract a little bit off of 4, and we're going to force the average to be 4. That's essentially what we're doing. We're forcing the average of these two numbers to be 4. Everything follows that pattern. Okay? All of those numbers follow that pattern. We're adding a little bit, subtracting a little bit. Okay? Like when we look at 1 and 7, we subtracted 3 and added 3. When we look at 2 and 6, we subtracted 2 and added 2. When we look at 3 and 5, we added 1 and subtracted 1, right? They're always balanced. those two numbers, 3 and 5, 4 plus 1, 4 minus 1. 2 and 6, 4 plus 2, 4 minus 2. 1 and 7, 4 plus 3, 4 minus 3. It doesn't matter the combination. Okay? They're always going to follow this pattern of 4 plus u, 4 minus u, whatever it is. Average plus u, average minus u. All right, so enough dwelling on that. And so those are the two numbers. They add to negative 8, and they need to multiply to be negative 48. And then that's where the equation that we're solving comes from. So negative 4 times negative 4 is 16, and u times negative u is negative u squared. Remember, that middle term is always just canceling out, so I'm not even going to bother writing it, equals negative 48. And then I add the u squared. I like to add it to the other side to get rid of the negative. And then I'm going to add the 48 to the other side. So I end up with 48 and 16 adds to, well, the first thing that I officially can't do in my head. I don't know why I'm struggling on that. 64 equals u squared. Take the square root, u equals 8. So again, we were on the hunt for my two factors up here. Well, we just found them. Negative 4 plus 8 and negative 4 minus 8. So we've got 4 and negative 12. So our two solutions in the end are negative 4 and positive 12. Again, it's the opposite of what's in the parentheses, right? Because why is that the solution? Why is that the solution? Well, when I plug in negative 4, I get 0. And 0 times anything equals 0, right? That's the point. We want it to equal 0. Um, I'm gonna keep going till you guys tell me to stop. I'm doing as much as I can to help benefit those of you who are still watching. And let's take a look at Desmos here. What did we do? What did we do last lesson? We plotted the left-hand side, we plotted the right-hand side, and figured out where they intersected. That still works. That still works. Wait, so the b value plays a part in what your answer is. In some sense, yes, right? I need to know b in order to determine this, right? If I would say that that's as much of a role as it takes. What happened? Didn't I write x equals negative 4 and x equals 12 somewhere? Am I crazy? Didn't I write this? Where did I just write that? Did I accidentally delete it? Am I losing my mind? So what did we do last? Oh, I didn't. I guess I didn't mean to delete it. Whoops. Apparently I had a brain fart. So what did we do last class? We graphed the left-hand side, we graphed the right-hand side, and we looked to see where it intersected. No, like the last step, you used negative 4 plus 8 You're using the b value? No, that's what u happened to become, right? The u that I solved for happened to be 8. Remember, b was -8, right? This happened to be 8, so boom, boom. Like in these examples here, right? My u value, like in this one here, ended up being 4, so I went boom, boom. B was -2. So I'll say my sentence one more time. So what did we do last class? We plotted the left hand side, we plotted the right hand side, and we looked to see where they intersected. And where are these two functions intersecting? At 4, at -4, and at 12, which are the two solutions that we found. Desmos still works, people. Desmos still works. Desmos still works. Oh, I can. And the 4 came from dividing the 8 by 2. Yes. -4. The -4 came from dividing the -8 by 2. Desmos still works. Let's look at another one. X squared minus 2x minus 15. X squared minus 2x minus 15. I plot the left-hand side. I plot the right-hand side. Where do they intersect? -3 and 5. Now, you might be asking yourself, well, why would I do this work by hand if I can just plug it into Desmos? Because you should learn it. You need to be able to factor, right? You need to be able to factor. I understand that the answers right here, x equals -3 and x equals 5, can be found via Desmos, but this cannot, right? Desmos is not going to factor it for you into x plus 3 and x minus 5. And that is a skill that we need to know. I am indeed, PJ. That is a skill we need to know. We need to know how to factor. Any of us in here want to ask a question about, just want to clear the air on anything? Or do you want to help me do, let's do another one where there's a fraction. This one's got a fraction. So we want to add to 13 and multiply to 36. It's going to take the form 13 halves plus u and 13 halves minus u equals 36. Don't overcomplicate it. 13 times 13, that's 169. If you don't know that, plug into a calculator. 2 times 2 is 4. The middle term cancels, and then minus u squared equals 36. Move that guy to the right side. Move the 36 to the left side. This is a positive 36. So I'm going to subtract it to the other side. Thanks, BJ. Appreciate you. So I'm going to subtract it to the other side. And I need to get a common denominator. So I'm going to multiply it by 4 over 4. 36 times 4 is 144. I had to type that in to a calculator. And 169 minus 144 is 25 fourths. And when I take the square root, I end up with 5 halves equals u. So what are my two numbers? Again, I'm trying to factor this into x times something, x times something, or x plus or minus something. So my two numbers are, I'm running out of room, I'm sorry, 13 halves plus 5 halves, right? That's the first one. And 13 halves minus 5 halves. So we end up with 13 plus 5 is 18 halves. 13 minus 5 is 8 halves. So 9 and 4. So my answers are -9 and -4. Can you believe I've only been live for an hour? It has felt like longer. I'm stressing. I'm definitely challenging myself here by going over this and going over it and going over it, right? I'm getting better and better as we speak with this method, right? It pays off to do so many examples in a row. I think I might download this video and cut it into multiple sections. Title it something nice for each one. So if you get a positive number, it switches to a negative. Right. The solution, because again, why is it switching to a negative? Because we're trying to get this thing equal to 0, right? To do a little bit of work down here, right? What are we saying? We're saying x squared plus 13x plus 36 equals x plus 9 times x plus 4. That is a true statement. These two things are equal. And we want it to equal 0. We're trying to set it equal to 0. So what x value sets it equal to 0? Well, if I plug in -9 here, if I plug in -9, what is -9 plus 9? 0. What's -9 plus 4? Well, who cares? Because 0 times anything equals 0. And we got our answer that we wanted, right? We want to know, what does x have to be in order for it to be 0? -9. Or the same thing's true for -4. -4 plus 4 is 0. 0 times anything equals 0. I don't know if the first question sent. I don't think I saw your first question. Can we use either the quadratic equation or Desmos to find the answer? Desmos and the quadratic equation will find you your equation, or so find you your answer. But neither will help you factor. Desmos won't help you factor, and the quadratic equation isn't gonna help you factor. So I like to look at this as a factoring method that then helps you find your answer. Because once I have my factors, I know my answers. So yes, you can use it, and if you want to completely avoid this, I suppose that's your choice. But I would not, because we are going to factor on multiple occasions for multiple reasons in multiple different lessons. Not just for the next few days, but repeatedly, factoring will come up, and then come up again, and then come up again. So I'm starting something here, something a little bit different. And if people don't watch this video, they are going to struggle. Well, I don't think they will, because you can always use Desmos. Again, as Isel Isel Uzi. I was kind of reading it as like Isabel there for a second. As Isel Uzi just said, you can just plug this into Desmos too. This one, like this one right here, you might have gotten intimidated by the fractions and you were like, oh great, I'm just gonna watch him do it, right? Again, what do? You plug in the left side of the equation, you plug in the right side, and you look to see where do they intersect one another. So let me show you where they intersect one another. I plugged in the left side. I plugged in the right side. Where do they intersect? At -4 and at -9. Those are the two solutions I just found. Desmos is not going to tell you the wrong answers, but Desmos is not going to tell you that it factors into x plus 9 times x plus 4, right? These guys are the exact same thing. Look at that. The blue graph, the black graph, they're the same. Blue and black are the same. They're the same graph. One is in standard form and one is in intercept form, or this factored form. Desmos is not going to convert this into this for you. It's just not, okay? And that's what we're doing. All right, so let's do something new and fresh together here. What happens if A isn't 1? If A doesn't equal 1, make it equal 1. So with that being said, oh heck. Thanks for the follow, my guy. Boom. Look at that. I made it equal 1. Now, granted, there is that fraction there, 7 halves. But that's okay. All right. That's okay. We can still do this. All right. So we want to add to 7 halves and multiply to -2. So we take half of 7 halves. That through. We take half of 7/2. That's 7/4. Oh. Equals -2. Hola, Crypty. How you doing? So when I multiply these two things together, I get 49/16. I'm gonna run out of room. Crap. Add the u squared, add the 2. I'm gonna run out of room big time. I'm just gonna say, you know what? Screw this other problem for right now, and I'm gonna move my work up here. So I end up with 32/16 plus 49/16 equals u squared. And 32 plus 49, what is that? 81. Take the square root, and I get 9/4 equals u. So, what are my two numbers in the end? Sorry, I'm super running out of room. I'm using up all of this space. They took the form 7/4 plus u and 7/4 minus u. So 7/4 plus 9/4, 7/4 minus 9/4. We end up with 9 plus 7 is 16/4, which equals 4. And 7 minus 9, which is -2/4, which is -1/2. So I end up with x plus 4 times x minus 1/2. I'm discovering something as I do this problem, that we didn't get a whole number for this answer. And it's not to say that that's bad, but it's not exactly good. So let me take a step back and realize here, what was the first thing we did? We got rid of the 2. We got rid of the 2. That was a lot on that one, Lil Nat. I will agree. That was a lot on that one. That was a lot on that one. But the thing is when I look at, so again, this is just me having a moment here with this method here that we're using to solve. When I look at I'm just completely ignoring this right here. When I look at the problem 2x squared plus 7x minus 4 equals 0, because of this 2 here, I can't just factor it into x times something, right? Because x times x is just x squared. Where's the 2 going to come from, right? So just jumping straight into it with 7 and 9, or sorry, 7 and -4, just isn't going to work. Because no matter how you look at it, x times x is not going to give me a 2x squared. So I kind of had to rethink the problem through and go, okay, if I can't get a 2, if there's no way, when I do x times x, if there's no way to get a 2, what do I do then? Well, that's why I got rid of it at the beginning, okay? That's why I got rid of it. Because whatever I do to one side, I can do to another. Valorant's alright. I do like Valorant. Thank you for the follow. So whatever I do to one side, I do to the other. And that's why I ended up with this. So after doing all this work here, after doing this work, this right here is the factored form of this, right? This is the factored form of this. But what is the factored form of that? Well, I'm going to do something on the fly here. This thing with the fraction, what number did we get rid of? What number did we get rid of? 2. Let's put it back. Let's put it back. So I'm just having some fun here. This is not like you're gonna need to know this right away, right off the top of your head, like any moment's notice. No, that's not what I'm saying. I'm having some fun here. So this is the factored form of this. 1. Plug into a calculator. Fractions are just things that you can plug into a calculator. 16 fraction bar just means division. Divided by 16 equals 1. 2 divided by 4. So 2/4, that's why it's a half, 0.5. 1 divided by 3, 1/3, it's 0.3 repeating. A fraction is just division. 9/4, 2.25. So if this right here is this guy, well then let's put that 2 back. Let's put the 2 back in place, all right? How are we going to do that? So let's do 2 times x minus a half times x plus 4. 2 times x is 2x. 2 times a half is -1. Ooh, baby, we did it. Check this out. Check this out. X plus 4 times x minus a half is the same thing as x squared plus 7 halves x minus 2. What? What? Oh, what is the 16 over 16? What up, Bucky? What is the 16 over 16? Gotcha. I'm getting a common denominator, right? This is 2 over 1. So 32 over 6. What's 32 over 16? It's 2. This 2 and this 32 over 16 are equivalent. I'm just simply rewriting it with a common denominator so that way I can add these two things together. I think the best way I learned quadratics was having a visual of the graph and creating derivations. Thanks for the follow. I think having a graph is definitely great, but if we're in a situation where, on an ACT portion where the graphing calculator is not allowed or something like that, or you don't have a graphing calculator or something like that. Also, a graph, I would say a graph can only be so good until it's like super weird numbers, right? The cleaner the numbers, the better. I feel like. So, start off by knowing what it makes, but you draw it here. Gotcha. So, this thing is this, but like I said, we divided by 2 to get to this point. Let's put the 2 back in there and check this out. 2x minus 1 times x plus 4. 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is negative 1x. Negative 1 times 4 is negative 4. And when I combine these two things together, I get 7x minus 4. Holy Toledo, Batman. That's what I started with. So this is the correct factored form. Oh baby, oh heckin' baby. Thanks for the bits. I think I'm gonna get some Cafe Rio. Light up the chat with emotes if you're pumped for me to get some cafe. If you actually not if you're pumped for me. If you love Cafe Rio. I was able to recently learn the roots that come with the graph just to help with intuition. Can you show us on Desmos? Those emotes for Cafe Rio. So, on a graph, right? Again, to because you obviously want to get the right answer, but I also want you to be able to factor. I want you to be able to get the right answer, but I want you to be able to factor. These are two different things. I'm not ignoring your question, Slow Turner, but I guess before I just go plugging in Desmos and showing you like, oh, you can just do it this way. Like the answers were the answers to this problem are -4.5, right? The answers. The factored form of 2x squared plus 7x minus 4 is 2x minus 1 times x plus 4. Desmos is not going to get you that factored form, and you need to have a strategy to get to that factored form, and that's what I'm showing us right here with this method that I'm using, right? But if we want the answer, right, it's as simple as plug in the left side of the equation, plug in the right side of the equation, and look to see where they intersect. So let's see where they intersect, and I'll show you that it is at 4 and 1/2. So 2x squared plus 7x minus 4. There's this green graph. Y equals 0 at -4 and at a half. And yes, Miles, Cafe Rio is delicious. So there's our two solutions at -4 and a half. So Desmos is still your friend. I encourage you to check your answers with Desmos, but I also highly encourage you to still keep trying this method. We're going to keep doing it over and over. I think it's a method worth learning. To be honest, I'm learning somewhat with you guys. I know that's how I started it. That's how I started this stream was by saying that we're kind of doing this a little bit as a team here, right? Desmos is my bestie. But Desmos will not tell you that the fact that that work that I put in, not the bash your bestie, but 2x minus 1 times x plus 4, it's just not going to tell you that, right? We solved for that. There's no like magic machine, right? That's going to tell you that. So the green graph and the black graph are the same. I can't stress that enough, right? This is standard form and this is this factored form, right? They're the same graph. But what's nice about this factored form is when it's in factored form, I can see the zeros. I can see, because that's what these are called, right? Don't forget that, right? I can see the zeros are at -4 and at 1/2, right? I can see that without even graphing. Because if I plug in -4, I get 0. If I plug in a half, I get 0. Oof. Not the classic Wahoo emotes. Let's do another one where A isn't 0 and see what happens together. Let's do one of these guys since I have plenty of space. First off, it's not set equal to 0. If there's one trend about every single one of these problems, it's that it's set equal to 0. That's a must. That's a necessity. So with that being said, let's set this equal to 0. Let's set this equal to 0. Okay. You're going to love this. You're going to love this. Like I said, if A isn't 1, then make it 1. And oh, you're going to love this. Everything just reduces. All of those reduced by a factor of 3. Nice and clean. Boom. There it is. So that's what Bucky's on to. How about scaling the quadratic factor function to a factor of 1? I think that's what you were getting at there, right? And that's how I started this problem right here, right? I divided everything by 2. But it didn't come out clean, right? It didn't when I say clean, I got a fraction. Here it came out clean to x squared plus 5x plus 4. So with that being said, what do we do now? It's been a minute, right? I've been talking, we've been looking at Desmos, been having some fun. At least I'm having some fun. We're looking for two numbers that add to 5 and multiply to 4. And again, some of us can just do that in our heads. What multiplies to 4 and adds to 5? 2 times 2 is 4. 2 plus 2 is 4. Doesn't work. What else multiplies to 4? 1 times 4 is 4. 4 plus 1 is 5. I'm done. Right? I'm not telling you you have to use this method every time. I'm saying that it works every time. If you can just kind of guess and check in your head, then great. But that's not what I'm here to do. I'm not here to guess and check. I'm here to get it right. So like I said, we take half the b value and we break it up like so. So let's crank this out. 5 halves times 5 halves is 25 fourths minus u squared. Gonna add the u squared to one side, add the 4 to the other side. And this is where wait, what did I say? I'm not here to do it. What did I say? I need to multiply this by 4 over 4. And I get 16 fourths plus 25 fourths, which equals u squared. $16 and 25 give me wait, what did I mess up? Did I mess something up? Oh, I have to subtract the 4. Ooh, 25 fourths minus 16 fourths, which is 9 fourths equals u squared. Take the square root. I get 3 halves. So 5 halves plus 3 halves is 8 halves. 5 halves minus 3 halves is 1 half. So I get 4 and a half. So again, because I minus 3 halves is 2 halves. Derp. I've been streaming too long, which is 1. So this factors into x plus 4 times x plus 1. Like I said, 4 times 4 is 5. 4 plus 1 is 4 times 1 is 4. 4 plus 1 is 5. So this factors into this, but remember, I started with this. So I need to multiply a 3 back in. I already have my answers. Don't get it mistaken. We already have our answers. X equals negative 4. X equals negative 1. Okay? But I do want to stress the fact that we're factoring. This guy right here factors into... We need to multiply a 3 back in, right? Because we took it out. Now we need to put it back in. So we get 3x plus 12 times x plus 1. I think I've probably done enough, and we're gonna keep doing more. Oh, let's plug this into Desmos. Here's the left hand side. Here's the right hand side. Ooh, check this out. This is gonna look different. None of our ones from last class looked this way, but that doesn't mean it's wrong. Ooh, check this out. We get negative 3x squared, and we have 15x plus 12. Where do the two graphs intersect? Oh, baby, baby, baby. Struggling. We got to find the intersection. They intersect at negative 4. There's solution number 1. And they intersect at x equals negative 1. There's the other solution. Now that graph's a little hard to read. I'm scrolling around and having to move around. What did I do to start? I set it equal to 0, didn't I? Right? I set it equal to 0. I can also plug that into Desmos. Plug in the left side, plug in the right side. Check this out. Let's do that. So we got 3x squared plus 15x plus 12. And then we have y equals 0. And where do they intersect? At -1 and at -4. Funny how that works out, eh? Right. Poggers. All right, what else did we do? Did we do anything fun? What did we do to end the stream? Anybody got any questions? Anybody want to? Do we do anything fun? What can we do? There's a method you can do. What's that? So I think the simpler quadratic formula that you're give me a random quadratic equation with any number. Hold on. Hold on. Let me make it a tough one. How about 2x squared plus x plus 3? Equals 0. All right, I did it. All right, so the b over 2, which I've been kind of using. So -1/4. So -1/4 plus or minus the square root of b over 2 negative b over 2 squared. So that'd be 1/16 minus 3. All right. Three over two. What? Oh, 3/2. Yes. My bad. I forgot we did that. Minus 3/2. And then, so no all over 2a in this situation, right? So negative 1/4 plus or minus the square root of, so 8/8. So that's 1/16 minus 24/16. So that gets me negative 1/4 plus or minus the square root of negative 23/16. Which is an imaginary number, right? Taking the square root of a negative. Yeah, it is. That was kind of what I meant by make it hard. So I'd have I over 4 root 23. Yeah. So, I mean, what that kind of is kind of my um I believe that's my if I do what I've been doing this whole time. So I think in the end it would be 1/4 plus or minus 23/4. Well, I can't take the square root of 23, so it would stay under the radical, right? So I would do, like, when I look at this here, I get negative 1/4 plus or minus the square root of negative 23 over the square root of 16. So I end up with negative 1/4 plus or minus I root 23 all over 4. I could write it like that too. So I think if I do what I've been doing, right, I take this, it needs to add to b and multiply to c. And this is b over 2 plus u, and this is b over 2 minus u, and that needs to equal c. So that's b over 4 minus u squared equals c. So b over 4 minus c equals u squared, which if I take the square root is b over 4 minus c, which that's, what did you tell me to do? You told me to do b over negative b over 2 squared, which the b over 2 squared, the 2 squared is going to give me a 4, but I've got minus c here. Yeah, it needs to be this method here that I'm doing. I'm always scaling it down to 1. Yeah, like what I did on this problem. I got rid of the 3, and this problem up here I got rid of the 2. So yeah, sometimes you get that fraction. I feel like the equation that you had me use can be derived here somehow. Um, so that's u. So u equals the square root of b over 4 minus c, right? Which if I got a common denominator, I could rewrite that as b over 4 minus 4c. So the two numbers are b over 2 plus, I could write that even better. So that equals the square root of b minus 4c all over 2. That equals u. So I've got b over 2 plus square root of b minus 4c all over 2. And I have b minus square root of b minus 4c all over 2. So I can rewrite that as b plus the square root of b minus. So basically, these two answers are plus or minus b plus or minus the square root of b minus 4c all over 2. So not quite the same as yours, but close. I think if I use this equation, it would work. Let's see. I think. So we got 2x squared plus x plus 3 equals 0. And then I divide it by 2, and I get x squared plus 1 half x plus 3 halves, like I said. Just double checking my work up there. So then 1 half plus or minus the square root of 1 half minus 4 times 3 halves all over 2, which equals 1 half plus or minus the square root of 1 half minus 12 halves all over 2. Where did I mess up? This doesn't look like it's coming out to be the same answer. So 1 half plus or minus the square root of negative 11 halves all over 2. Did I mess up somewhere? Bucky, you still with me? Yeah, I don't plan on doing every single one of these examples, and I'm not gonna do the word problems today. Sorry to keep you hanging, little Nat. That's what I was saying. Like, what should we do to end the stream for fun? Because yeah, I think I covered enough for all of us to watch, to soak in. Does keep it up with your bestie. I wanna double check my work here real quick. So I said b over 2 plus u, b over 2 minus u. So that's b squared minus u squared. You too, little Nat. So this is b squared b squared, b squared, b squared, b squared, b squared, b squared, squared, 1/2 squared, 1/4. So then this is, I need to get a common denominator. Do you see what's happening? I'm going to have minus 24. 1 minus 24. So that's negative 23 fourths. Which 1/2 plus or minus I root 23 all over 2 divided by 2, which becomes 1/4 plus or minus I root 23 all over 4, which is the same answer that we got earlier. Wow. $23. I think that's the fun note that we ended on. I've been live for about a couple hours. I'm feeling hot. I'm feeling burnout from math. This was a great stream, though. Bucky, I appreciate you for tuning in and playing that game with me there. Slow Turner, Lil Nat, who already left. The others of you, Izelle. Dude, my chats never go through for some reason. Lol. Very strange. Bye, I sell Uzi. Anybody else out there? Thanks for watching. I'm gonna have to splice up this replay into bite-sized bites.